Welcome to the Intersecting Us podcast, where math and life intersect.
In today's podcast, Brian and Dave talk about the permanence in math and existence.
Intersecting Us is about intersecting a lot of things, but mostly math and life. And one of the things we did very early in our endeavor was to make some videos, both kind of on the life side and on the math side, that had to do with eternity and infinity. And today on the podcast, we're going to talk about the word permanence, which has some of that idea of unchanging and endearing and qualities that keep on going, like eternity and infinity. And we're going to look at a little bit of, again, Francis Sue's book, which has a chapter on by that name of permanence. But I'm going to bring in Dave here because from the math side, he did some really good videos on that, on infinity and how that worked in math and how that makes us be able to make calculations and all those types of things. So Dave, this chapter kind of probably resonated and hit home in some ways.
Yeah, it certainly did. In fact, unfortunately, I've got some bad news for the listening audience as I think about what we're doing. And I think that if we would take an inventory of our lives for the day, I know for us here in Des Moines, we're expecting snow and just got done with a workout, had some lunch, did a little bit of work, all that kind of stuff. And as I inventory that, the bad news is that pretty much none of that will be permanent. It will likely all be gone either by tomorrow or next week or next year. But, even if we go out 10 years from now, likely none of that will be permanent. And so that sometimes can be a sobering thought as we put so much effort into our day-to-day activities, realizing that so much of it really is not permanent.
Yeah, and I think that was what we kind of talked about in our video series. And then it's kind of been, I think, kind of the quintessential background idea in Intersecting Us, that even though there are many, many things, as you said, that are not permanent, not eternal, we wanted people to think about using math and then other concepts in life, philosophy and things, that maybe there are some things that are permanent. Because I know in the chapter there were different quotes. They talked about the universe, they talked about logic, I think science, even mathematics, and about how those things can be seen as eternal or permanent. Because I guess existentially or emotionally, when we think about our lives, if we are thinking about them as non-permanent or temporal, it can get a little depressing sometimes. You're like, well, okay, I do the workout, you did a workout, and that has some lasting effects. I'm not saying it's just for the moment, but it doesn't last forever because our bodies don't last forever. So that kind of feeds into this thing where we're looking for, I guess you're going to define permanence. It's something along the line, something that's unchanging and enduring, endures and it doesn't change, I think is a good definition of permanence.
Right. We have a little bit of history, you and I, because you and I started way back in 1987. So that is a long time ago when we started working together, and then started our own business in 95. Not much of that business is still, I would say, around from what you and I started back in 1995.
Yeah, there's not much left, although there's a few enduring qualities. I don't know. You would know better than I would, I think.
Maybe a few insurance policies are still using our technologies that we developed back then, but probably not too many. But on the other side, it's built for things that are part of reality. So I think what you and I started in 95 was the foundation for coaching actuaries, for example. And, even though you and I didn't develop coaching actuaries together, what we started was the foundation that allowed, coaching actuaries to be created. And so sometimes we shouldn't just dismiss things that aren't permanent because they may move into something that looks different, but certainly has value. And so I think that patience is a word that comes to mind when I think about some of these things that, are important and lasting. They may not be forever, but patience really helps us, I think, to see the long-term perspective.
Well, and I think, as we look into a lot of what Francis Sue's doing, I mean, he always kind of puts that word virtue in there. What's the virtue that you can get off of permanence? Because permanence by itself is not really a virtue. It's just kind of a concept. But patience is, patience, in fact, that's what patience is, a virtue is in a lot of different worldviews. But I think it's something, and he has said this, I think, in most of his chapters, but it's like permanence is a universal human desire. I mean, I think that's something we all want. One of the things that, again, I always think the medium of our culture is more movies than books, although they cross over. But I think about the Marvel movies, with the different characters there that had, I guess, some sort of almost immortal. They could live longer, they could do more things than there was some sort of permanence there that, whatever. I don't want to mix up. I know there's DC and Marvel. I don't want to mix those up, but I know like the Thors and the Captain Americas and all those types of things. There's an immortality to them that we kind of like to see. They're going to be there, and they have endurance, and they have the virtue of caring about other people and all that kind of stuff. But really what it comes down to sometimes when we look at permanence, it's especially as you started off, it's not really us so much that we look as permanence, but what we do. Do we leave a lasting legacy or something like that? And I think that's what you're talking about a little bit with coaching actuaries and Salt Solutions and all those things. There was some foundation we used in there that I think is still being used. Some of the virtues that were there, I think, are there, but a lot of think what we were programming in back then, and the type of, heck, we were still using HP calculators sometimes. That wasn't permanent. I mean, you could use it if you want, but now it's just a glorified paperweight. It's just a different way of looking at things. So there's permanence there, but there's not. It's what is permanent and what is not, I think, is the thing. And I know he hit that in the chapter when he talked about like constants and invariables. When he was looking at math.
Right. Yeah. And with math, there's a quote from a guy who I'd never heard of before. His name is Oliver Heaviside, if I'm pronouncing it right. But his quote is, logic can be patient because it is eternal. And I think with math, we've got time on our side because what we discover in math is permanent. Now, obviously, if you're studying for a test that's coming up this Friday, you don't have all eternity to prepare for that test. The reality is this Friday, the test is there. So, but when we learn math after the test on Friday, what you've learned will remain true, not only the rest of your life, but, for all of eternity. And so that's one of the beautiful things about math. And I hadn't thought about before, but he brought in some of our favorite constants of E and pi, and that, those numbers have been discovered a long time ago, but they weren't invented because it was just a discovery. I mean, those numbers have always existed. Pi is connected to a circle, and E basically connects to exponential growth. And those, pi hasn't changed, E hasn't changed. And so as we use those numbers, and the cool thing about math he talks about is not that it's just a matter of facts. So facts is like pi is 3.14. True, that is pi, but it has so much more depth to it that mathematicians really kind of go on a treasure hunt, learning new things about pi that are simply interesting and surprising and fun to kind of understand. And so there's this permanence to these numbers, but there's also mysteries that we're still understanding. Obviously we don't know all the digits. That's part of the mystery. There's an infinite number of digits. So we're always learning, new digits, but that's just the beginning of the iceberg. There's so many patterns and relationships and depth to these numbers that we're uncovering that, truly are pieces of art.
Yeah, and when you look at those, I thought that was so ironic when I was reading through that for a second time. It's like, yeah, there they are. Those constants that that math has. But I think, when he went into that, he has those three things that we can talk about as we go through. But, he asked the question, why do we seek it? Well, I think anybody listening is like, well, yeah, you want some permanence, whether it's in a relationship, a job, a car, something that has some sort of things you can, but he says it's because he used the word refuge. We seek permanence because there's stability is a safe haven, something we can always rely on. And I think all the chapters, I think, and all the things we've talked about, goodness, beauty, meaning, all those things, there is that permanent part of that gives us some sort of intellectual permanence, but there's also kind of an emotional, existential permanence that we all want, that refuge that we can always go back to, and math does that. You've got a circle. No matter when you start trying to calculate circles and spheres, you're going to have to use pi, and that won't change. And that's the thing that I think is it's a great springboard. And he did a great job of doing that with the word refuge, because I do think in our lives, isn't that what we're seeking? You talked about exams. Is there an exam coming up? An actuarial exam?
P is in January. Yeah. So P is just starting right now.
I thought there was one that was coming up. So, but think about that as exams. It's a great analogy or just illustration. The idea of, why are you taking that exam? Well, there's lots of different reasons, but that makes your job have more of a refuge. We all know that if we don't perform in exams or in our jobs as well as we'd like, that refuge might go away, So there's that emotional part too. Now we're talking about more than just a job. We're talking about life and maybe beyond life when we talk about our life anyway, eternity. But refuge, I thought, was a good word that he used.
Yeah. And I can share from my own experience that concept, because, we all go through ups and downs. And within the last few years, I went through a down period that was, really difficult. And one of the things that really helped me through that was doing math and just pulling out problems that I was toying with, reading about the history of math, and discovering new things. It was a way that is difficult to explain, but it was kind of like a refuge for me when things had been like falling apart. Math was always a stable foundation that I could grow on and discover. And, for me, math is not just a subject, because the things that I care about, my personal faith, all those things are connected, because I see math as part of that. And so when I, work on math, I also see kind of like fingerprints of eternity speaking to me. And so that was something that meant a lot to me when I was going through a down period, and it provided kind of a solid foundation when other things that were part of my foundation, started to crumble.
Yeah, and I think you see that a little bit in, I lost the guys. Is it Chris, the letter?
Yes, Chris. Yep.
You see that in the background and sometimes in the foreground of some of the letters, if you're reading the book, that you see that for him, he's in prison. And so, he could maybe quintessentially going through some of the same stuff you did, at least, with not having everything going the way he wants. And, some of it may be self-inflicted. But the idea of having something permanent in math for him was similar, that he could go back on that. He could rely on that, because a lot of times things in life we can't rely on as much, or we thought we could, and then we couldn't.
Right.
And math does provide that stability and that refuge that, it's going to be the same if you may have more than one way to solve a problem or prove a theorem, but the theorem's still there and not going anywhere. And right. that crosses over pretty good.
Right. And, I want to kind of paint a fuller picture, because it's not, if we look at the whole spectrum, it's not just the permanence. You kind of have to look at the entire book, because for me personally, it's not like I could just look at it and say, oh, gee, 1 + 1 is still equal to 2. I mean, that is permanent, but that doesn't really do too much to me or for me. But what I'm talking about are things that you discover. And so you're discovering new things about things that are permanent. And so as I was like discovering new things about, let's say, circles or triangles or you name it, I kind of looked at a lot of things, but geometry is always kind of like a fun thing. And so it was fun to discover, but it was also cool that what I was discovering was the same thing that Euclid was thinking about 2,000 years ago and Euler was thinking about 250 years ago. And so there was this permanence to the joy of discovery and not just, well, gee, we both got the same answer, 2 + 2 = 4. That really wasn't it at all. It was about, the joy of math. And then on one side of the coin and then on the other side of the coin, realizing this is also permanent. And so, that kind of is a double benefit when something you're experiencing also has lasting value.
Yeah. And I think that's it. It's not just like you said, it's just, well, this worked once, it'll work again, which is, part of it, but it's the idea of the whole concept. The whole concept, you're finding things that are reliable. So you might be able to find more things that are reliable. And as we talked about, exploring all that stuff, we had one on exploring.
Yeah. So chapter 2 is on exploring. Chapter 4 was playing. I was playing. And then chapter 5 is on beauty. And that's probably the part that drew me the most was the things that I was discovering really were just beautiful. But it had additional benefit than when you throw in the fact that it was permanent. And it's like, wow, not only is it beautiful, but now this is something that I can treasure for a lifetime. This is something that a stock market crash is not going to take this away, or, whatever calamity may hit, I can count on this still being true and beautiful.
Yeah. And I think that kind of goes into one of the other reasons he put in why we seek permanence was a foothold. The idea of he used, I think, an analogy of somebody climbing a wall or a rock wall or, cliff climbing or whatever, that you're looking for where to put your feet. So when you put it there, you're not going to fall. You can rely on that foothold, it's similar to the idea of a refuge, but it's got a little bit more, it's just maybe a little bit different analogy and a different way of looking at it. But you have those things that you can always rely on knowing that it's there. And kind of back to what you were talking about, Dave, the idea of within math, you have those, but it's more of the idea that that's part of math, that there are things that are can foothold. You might not even know some of them now. You keep discovering, like you said, and exploring, but they've been there in the past. So it's logical to think that there more likely be more in the future, and we may find more. I think one of the quotes that was in there, or one of the quotes that you had that I thought was pretty good was, it was talking about equations. It was anytime you get an Einstein quote, it's a good quote. But he was, equations and he gets into constants and invariance and all that stuff in the book. But, politics is for the present, but an equation is for eternity. And I thought, here we are coming up on an election year, and that's important stuff. And it makes a difference in life. But that's, looking at the equation, and Einstein was looking at that, the eternity, there's a foothold there. There's something that you can always rely on. And it doesn't mean that we poo-poo politics or we think it's not, it's just, that's not the nature of the beast. But in politics, which is ultimately just polis, it's just people interacting with each other. Well, when we interact each other in a math way, we in the background have this refuge and this foothold that we can always rely on. So you hope it crosses over into life where people are saying, well, there are people, if not, some of the virtues of the people that we can count on, that we can just, the risk of that foothold not being there is just, it's not even something I'm going to fathom. It goes to zero, as they say. Yeah.
And that's one of the things that is really sometimes so easy to overlook about math, because math is part of this abstract world that we create in our mind, and yet it surprisingly connects to our physical world. And there's no explanation as to why it occurs. And so, maybe a classic example is, okay, the planets orbit around the sun in the form of an ellipse. Okay, why an ellipse? Why does an ellipse show up in the orbit? There certainly are things that we can look at from a physical world to explain it. But the bottom line is that an ellipse showed up as planets were going around the world. And so, as we were studying ellipses, we studied ellipses way before we knew that that's how planets orbited the Earth. And so it's just amazing that there's a connection between the abstract math world that we discover / invent and then the actual physical world. Another quote that I really liked was from Galileo. And he said, the universe is a grand book that cannot be understood unless one first learns to comprehend the language and read the letters in which it is composed. It is written in the language of mathematics. And so as we think about permanence, the things that we see in this real world have been kind of set in motion. Gravity, all that stuff is pretty permanent. I don't think we're worrying about gravity stopping anytime soon. And yet, why does gravity, why does math explain gravity? So all these things are really kind of deep mysteries that math can help us. It's the language that helps us to understand all of this.
Well, and as you said that, and there may be, if there are more scientifically inclined people listening, they can correct. But I think we know, like you said, mathematics explains the permanence of gravity and how it interacts based on mass and distance and all that stuff. But it doesn't really, if I understand it right, it doesn't really tell us why. Why does, the sun cause this? It really comes down to why does matter? And the bigger the matter, obviously, that's when we get into the big things like suns and planets and stars. Why does matter attract other matter? It just seems to be and in a specific way that, as Einstein has said before, that in an ordered way that kind of almost seems like a miracle, the idea. Mm-hmm. So, math can explain the permanence. Mm-hmm. And I do think if you cross over, which I like to do, into philosophy or even theology, we think of ourselves, and we probed that many moons ago about in different podcasts and videos. What about our permanence? Our ability. We're finite physically. We know that mortal. Even though I like the Marvel movies, I'm not one of those guys or ladies. But are there? If math can explain gravity and show the permanence of that, can philosophy or theology explain life and interaction and relationships, and maybe give some at least theoretical views or some hypothesis of what's permanent there? Even the why question. Why have these deep relationships in a temporal world if we're assuming that they don't continue past a certain time? They aren't permanent. You could say because that's the way it is. I realize it, but just asking the question, which I think math does for us. Math says, well, okay, we're going to try to figure out how this works. And then maybe we can get to some questions with the footholds and the stability that we have. And then maybe we can get to some questions on why it's doing what it's doing.
Mm-hmm. One of the things I've been playing with for the last month or two has been one of these equations that is eternal that we, I think, underappreciate. That's the Pythagorean Theorem. And you probably remember a little bit of that from geometry, I'm sure, Brian, right?
Yeah, that's something to do with the triangle, I'm pretty sure.
Yep, you got it. So, yeah, something to do with triangles. So anyway, I've been playing with that. And, as, the facts are, a squared plus b squared equals c squared, where a and b are the sides of a right triangle, and then c is the hypotenuse. And there's this relationship, this formula that we can use to, solve, if you want to think about it, solve for the missing piece of a triangle, right triangle. So, if you are, let's say, building a floor and you want to know whether it's square, you can, literally mark off 4 in one direction and 3 in the other direction. And then if you measure the diagonal that connects those two pieces, and if that's 5, then you've got a right angle, which I guess is the converse of the Pythagorean theorem, which is also true. So that I guess I threw an extra bonus equation at you, is that not only is the Pythagorean theorem true, but its converse is true, which meaning if you have a squared plus b squared equals c squared, then you must have a right triangle. And so, but bottom line is we have this permanent logic in place that is always there. And what I've been, why would I spend a month or two of my, time, discovering, playing with this? And it's because there are literally so many really cool things that are part of this relationship that you need to play with and dig deeper. And fortunately, there's been so much written about it. So, Euclid started the proof. Well, one of the first proofs was Euclid way back in his days. And so he's like the king of this. And, he wrote the Elements. So he would be the iconic person to talk about this theorem, in addition to Pythagoras himself, who was not the first person to discover this, but it's got his name on it. But there's been people over the generations that have added to that, come up with new ways to prove the same thing. And that is so cool on so many different levels, because one thing is it really highlights the fact that this really is permanently true, because we can look at it from so many different ways. And there's not a concern that we're going to come up with a new way of looking at it where it is not true. It's not permanently true. But just coming up with different proofs is, still kind of the beginning of it. It's, it's looking at how the proofs related to each other, and then what new things that they uncover about triangles and area. And it just goes on and on. But it's like an ocean of discovery, all embedded into this permanent idea that simplifies to, a squared plus b squared equals c squared.
Well, and I think as we wrap up the idea of the footholds there again, you've got that foothold. That's not going anywhere. And in this case, you're actually looking at different ways to show that foothold's true, which I think may lead to other types of innovations and discoveries. And I think one of the things he ended up with, which I think will kind of catapult us into our next podcast, because the next chapter is about truth, which is, kind of permeating our conversation a little bit, but we'll get into it deeper in the next one. But he asked, what is at the heart of the desire for permanence? And he used the word trust, whom or what can I trust, right. And you're talking about, I can trust that, like you said, that a squared plus b squared equals c squared. That's something I can trust. It gives me my foothold. And then I can move on from that, but I don't go away from it either. I mean, I go back to it a lot, that foothold's there. And it's always going to be there. And I can use it as the main thing in what I'm doing, or I can use it as a foothold to go somewhere else, or both, and that, I think that's what, and I like the way he put it, in whom or what can I trust? Because that's really what his book's about, kind of what our endeavor's about. It's like, the what is kind of the math stuff and the different, but the whom is the people and the life and all those kinds of things that go together with that. So he talks about trusting in reason or logic, and that is built in the permanence of math.
Right. And I really like how this chapter is sandwiched between beauty and truth, because as I've played with this, which was right before beauty, but as I played with this theorem, the beauty of it and the truth of it is, the essence is that is why I enjoy playing with it, is that there's beauty and there's truth and there is permanence. And so I have, actually came up with things that I think may have been new discoveries with regard to this proof that, I'll be kind of sharing in videos and stuff. So I'm kind of anxious to do that because I am creating a video series about this. And it's fun to, even if it's like a footnote into the long history of this theorem, maybe if you can add a footnote to something that is permanent, to me, that's kind of a thrill.
Well, I think it is. It's like some of the greatest teachers use different analogies, illustrations, parables to tell the same truth, because looking at it from different perspectives makes sense. So, well, I think if it works, I like it's not the last paragraph, but I just thought it was really good. And I think it'll catapult us into our next podcast about truth. And this is direct quote from Francis Sue's book. Most of our knowledge in life involves points of view, uncertainty, error, and incomplete information. So our knowledge is subject to revision. But mathematical truths don't get overturned. Their interpretations may change or they may become irrelevant, but their truth stays the same yesterday, today, and forever. That was a really good quote. So thanks for joining us in this podcast. We're going to talk about truth in our next one. So we hope you join us for that one too here at Intersecting Us.
This has been the Intersecting Us podcast. To further engage with Intersecting Us, go to intersectingus.com.